Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating shader toy called Tiny Clouds, a marvel of concise code that generates incredibly realistic cloud visuals. It's amazing.
280 characters? That's mind-blowing. I'm eager to hear how such a short program achieves such photorealistic results. What's the core magic?
The core is a clever ray marching technique. Instead of marching from near to far, it goes backwards, from far to near. This simplifies the alpha blending calculations, a crucial step in rendering translucent objects like clouds.
That's a smart optimization. So it's essentially tracing rays through the scene, sampling data at each step to determine if the ray is inside or outside a cloud?
Exactly. It uses fractal Brownian motion, FBM, data, sampled from a white noise texture. The FBM provides the organic, irregular shapes characteristic of clouds. Each ray step samples multiple octaves of this noise, using a scaling factor S to control the detail at each level.
And how does it determine cloud density?
The vertical distance from the ray's position to the cloud surface, represented by F, dictates the density. A negative F means the ray is inside the cloud, and the absolute value of F determines the cloud's opacity at that point. It's all incredibly efficient.
The code itself is remarkably compact. The use of a single-line for loop with commas instead of semicolons is a clever space-saving trick, right?
Absolutely. It avoids the need for curly braces, saving precious characters. And the hashtag #defineT macro cleverly encapsulates the texture sampling and octave scaling, making the main loop incredibly concise. It's a testament to the author's skill in code optimization.
I'm curious about the choice of reversing the sky color. Why not use the actual sky blue directly?
That's a great question. Using the inverse color ensures that red components fade out faster than blue, creating a more natural cloud appearance. It's a subtle but important detail for realism. The author cleverly avoids the extra characters needed for a more complex color calculation.
So, the sin.x term in the loop initialization, what's its purpose?
That adds a bit of noise to the ray's starting position, breaking up the potentially boxy appearance of the voxelized cloud data. It helps make the clouds look more organic. While seemingly unnecessary, it's a nice touch for visual enhancement. The author mentioned it would be removed if character count was critical.
Fascinating. The article also mentions replacing the white noise texture with a function. What were the trade-offs?
Using a noise function instead of a texture lookup resulted in a noticeable performance decrease. It highlights the efficiency of texture-based sampling in this context. However, in more complex renderers, moving noise generation out of texture reads could be beneficial. It's all about profiling and optimization.
This shader toy is a true masterpiece of concise coding and clever optimization. The author's understanding of both graphics programming and code golfing is truly impressive. It's a great example of how much can be achieved with minimal code.
Absolutely. It's a fantastic example of elegant code and efficient algorithms. The article's detailed breakdown is incredibly helpful for understanding the intricacies of this impressive piece of code. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of shader programming. Goodbye.
Bye-bye.